So it's getting recorded, right? So can somebody confirm? Yeah, I think.
I guess it is not.
No, it's recording.
It's recording. Yeah.
It's recording, I think.
Okay. So we can start with the first problem. It's like maximum number of balloons. We are given a string text, and we want to. You are supposed to use the characters of a text to form as many instances of the word balloon as possible. And you can use each character in the text at most once. That is either 0 or 1. And you have to return the maximum number of instances that you can form out of it. So if you look at the first example, out of this string, you can form this text only once. A balloon you can form only once, like B, A you'll have. So next time if you search for B, you'll get that B will be exhausted. Here similarly you can find 2 times, and in lead code, it's not possible to find B over here. And constraint is like you have the text length will range from 1 to 10 raised to the power 4, and they'll consist of only lower English case letters. So how do you proceed like here?
Yeah, we can make use of hash map.
Yeah, like could you explain?
So what we can do is like we can make the count of each and every character. So from that character, what we can do is we want the word balloon only. So we'll see how many times B is occurring, how many times A is occurring, L as well as O and N. So then what we will do is we'll just take the minimum number count of all these characters.
Okay.
So in that case, it will. So for example, if we take this example, so here B is occurring once, and A is occurring once, and LL is occurring twice. So in the word balloon also, LL is occurring twice, and O is occurring once, and N is 1, and E and K are occurring 1. So if we make the minimum of all this count variable, so the minimum value which we will get is the value of 1, which we can return it as an answer.
Okay. Yeah.
So the time complexity will be order of n, and the space complexity will be order of n in the worst case.
So you're passing through the string only once, right?
Yeah.
You want to share the code?
Yeah, I can share the code. So you can see my screen, right?
Yeah.
Hello. Yeah. So here what I'm doing is I'm making a dictionary with all this text as a word. So what I will be getting is the count of all. Let me print it out so that it will be more clear. So here for this word, L is occurring twice, O is occurring twice, N 1 time, A 1 time, E 1 time, B and K are 1 times. So what I'm doing is for the word balloon, B, A, N should occur once, and LL and O should occur twice. So what I'm doing is I'm taking the minimum of all this count of values. So if it is less than 1, there might be the case where only a single L is present. In that case, we'll be getting a decimal value. I mean, so in that case, there won't be. I'll be returning a value of 0. If not, I'll be returning the minimum value.
I don't understand Python. Is that counter a built-in function?
So what it will, in Python, counter is a built-in function. What it will do is it parse each and every character in the string and make a count of how many times it is occurring. For example, if we take NALL, this string, so L is occurring twice, right, in the string.
Yeah.
For example, if we take apple, what this will do is it will make count of each and every character how many times it is occurring. So A is occurring once, P is occurring twice, and L is occurring once, E is occurring once. So I'll be having like this count of each and every character in the string, how many times it is occurring. In Python, there is a built-in function called counter, which does to me, or else I have to manually write a loop of each character. So I can do like this also. I can explain. So if I don't use the counter.
Okay. So internally, counter will also take order of n only, right? I mean, in the background.
Yeah. Yes.
Is it allowed to use like such functions in the interview, like libraries and all in Python?
Depends.
No. Yeah, you can use it.
I think this is basic, so we can use, I guess. If not, also it's like a simple. We can initialize with default dict of integer value and just loop we can create an empty dictionary, and for each and every character in the text in the string, maybe you can have like this length of text. So if the text of that particular character, if it is in the dictionary, if we can write either dict dot keys or just this. So if it is present, I will increment that particular character with +1. If it is not present, then I will initialize that particular, dict of text of I equal to 1. Here also dict of. So this whole functionality is done by the counter. So I'm taking each and every character. If it is present in the dictionary, then I'll just be incrementing. If not, I'll be initializing in the dictionary, in the hash map, with a character and initializing a value 1. So for example, if we take this word NLA, this, or else I'll just take a simple example. So apple, let's take apple. So initially A will come, as A is not in the dictionary. Initially dictionary will be empty. First A character will come. So A is not present in the dictionary. So dictionary of A, it goes to the else. So dictionary of A will have the value 1. Next P comes. So as P is not in the dictionary, dictionary of P will have the value 1. And next again P comes, it will check in the dictionary, as P is already present in the dictionary, that is hash map, it will just increment the value. So the all earlier value it is 1, so it plus 1 it gets added. So dictionary of P will have the value 2. Again L will come. So as L is not present in the dictionary, it will go to the else part, and it will get a dictionary of L will have the value 1. Next E comes, and this is not present in the dictionary. It will go to the else part and get initialized with the value 1. So this whole functionality is done by the counter in Python.
Yeah, good.
So only thing is, I think you don't need line number 7 and 8 because you get the minimum of all the letters, right? So you will get 0. So
Minimum of. Sorry.
the thing is, yeah, here you get the minimum of everything, right? Like if there is L, if there is no L, you'll get 0. So you can just return answer directly.
So if can you just tell me the test case? Word text.
No, like 7 and 8 you can remove.
7 and 8. No. For example, if we have if we have a test case like this.
No, that time, like you have to change. If you go back to your min function, right? So there you have to do double, like instead of single, divide by 2.
I can do that also. Yeah.
So that way you get the
In
full
this
integer.
I can do.
Yeah. So this way you don't need
in
7
that
and
case
8.
it will be
Yeah, you don't need 7 and 8.
That's true. Yeah, that's true. I can do in that or either this also.
Yeah.
Yeah, this is. So time complexity will be order of n.
And space complexity also same, right?
Yeah, space also will have order of n.
Okay.
Because I'm storing each and every character in the dictionary hash map.
But I mean, text will consist only of letters A to Z.
26 letters. Yeah.
It could be right.
Constant.
It could be constant.
Yeah, order of 26. It can be like we can say constant. It as order of n. Constant. Constant space. Sorry.
Yeah.
Cool. Yeah, good.
Yeah. I'll stop sharing my screen.
Yeah. Thank you.
It's almost the same thing. I mean, rather than explicitly using that counter, taken all the variables from A to Z, and each letter, if you find, for every letter in the text, if that is present in your dictionary, then just increase its value by 1 and just get the minimum. And this is what he was saying. Like, I think the previous speaker, like, that, what do you say, division modulo you can take. Then we don't need to use answer less than 1. Yeah. So it's almost like order of n for parsing the string, and for constant extra space. I mean, a constant extra space will be used for that English alphabet letters.
So on this line number 5, instead of having all these A to Z, you could have just said balloon.
Yes, sir. Exactly. That was I was going to say.
Yeah, that should.
Is it possible?
Work.
Just a question. I'm not suggesting.
I'm not sure. It should work because those are the only things which we need in our dictionary.
Yeah.
Should work.
But in your solution, it won't work.
You do
because
not
the text may contain other letters than balloon, right?
Pardon?
Yeah, you can use single L also. Yeah, that's fine.
Yeah.
Oh, yeah, single. Yeah, definitely.
Yeah, but it works. Anyway, it works. Yeah.
No. So, any other ideas, or apart from this?
Sir, I did the same in C++.
Yeah, sure. Can share it.
So is it visible?
Yes, yes.
Yes, sir. So basically, I did the same. Like, first of all, I took an this unordered map, and then I took a string s, which is equal to balloon, and then what I did, I inserted each and every element of this balloon into this map, unordered map, balloon. Okay, then from line number 10. Um, line number 10, what I did, I started inserting those elements from this given string, given text, if that element is already present in our if it's present, like that if the letter is one of from this balloon string, so then we will increase it frequency. Okay, so yeah, it's that, and then in the end, I guess it's pretty much, congested in the way like all you guys did in this Python thing.
And what is that start to, like minimum start to not equal to line number 26?
This one. Yeah, so basically I took the case of balloon of it being twice, it's occurring twice, right? The balloon and this O
Double-ended.
thing. Yes,
Yeah,
yes, yes.
Got
So what I did, if minimum, after traversing all this from all the letters of B, A, L, O, N, if at the end, if minimum of minimum into 2, if that's not the frequency of L and O, frequency of L and O, if that's not equal, then minimum will be set to whatever which of those like minimum of their two.
Right.
Those two.
Yeah.
Yeah.
Yes, sir.
You can insert in unordered map based on the text itself, right? Then you don't need line number 10 to line number 17. Yeah, I think you can. Yeah, you can just, if you insert based on the text itself, like balloon, then you don't need even, you can take out up to 30, 10 to 30, and just calculate the minimum of all the letters of balloon.
Yeah, but then you have to do this thing, right? You have to find the minimum also.
Yeah,
Like
so,
first you have to increase the frequency. You have to set the frequency, like for this thing.
Yeah,
this
that you
thing,
can,
for example, too.
yeah, you can do based on the text, right? Based on balloon.
Okay. Yeah.
String.
You are saying like I could do the same within that loop itself.
Yeah,
One loop
instead
itself.
of insert and
Yeah.
then the next one, 10 to
Right.
16. Yeah.
Right. Yeah.
Yeah, in the end, you can calculate based just the minimum.
Yes. Yeah.
So here also time complexity is n only, but passes are more, right?
Passes also 2, right? Almost.
Yeah,
Once through the text and
will-
once to the map, So,
Yeah.
1 plus something. 1 plus the length of balloon.
Balloon, yeah.
On line number 26,
Sorry, you were saying something?
yeah, on line number 26, why are you checking for not equal to? I mean, I think,
Yeah.
don't you think we should be checking for less than or something?
Actually, it was some kind of rectifier. Earlier, I mistaken the question. I mistaken my concept with this thing like of unordered map. So I forgot that it contains a unique key. It does have a key. So after having this, after having to these lines, so what I did, I forgot that thing. So in order to rectify that thing, what I did, like if the minimum answer till now, after traversing through all the elements of that of my map, if at the end, if twice of minimum, if that is not equal to, if that is not equal to the frequency of the occurrence of L and or if that is not equal to occurrence of this O, twice of that, twice of minimum. If that is not equal to occurrence of this L and O, then what I did, I took the minimum of the two. Like if L is 3 and L is occurred 3 times and O is occurred 5 times, so I took half of both of them and minimum of them. So my answer would be then 3 by 2, which is equal to 1.
Okay. And what if, let's say, till line number 25, your minimum was 5. Okay. So basically,
Yeah.
B, A, and N exist 5 times. Okay. And at line number 26, L and O exist 12 times, let's say. Okay.
Yeah.
So 5 into 2, 10, not equal to 12. We'll get inside the follow on line number 28. Right? It'll pass this condition and it'll get inside line number 28, right?
Yeah.
And then you will check for minimum of frequency of O or L, which is 12 by 2, and 12 by 2 is 6, right?
Yeah.
So you will be comparing taking minimum of 6 and 6, right? So minimum will be 6, right?
Yeah, right.
Whereas B, A, and N occurred only 5 times.
Yes.
Yeah, that's a good catch actually, Ronnie. Can we have special test case like that and quickly run and see, Gaurav?
Yeah, basically we can just have B, A, and N. Like the frequency of L and O should be twice more than the frequency of B, A, and N.
Yeah, something you might have to change the condition on 26 line. So it should not be a big deal though, but yeah, instead of not equal to, you should have something. Yeah.
It should be this, right? Like if the minimum of 2 into 2, it should be greater than, right? Greater than, it should be greater than or equal to, right?
But if that is greater than or equal to, then you could as well just return the m's as whatever the value is, right? Instead of coming here.
You can keep it like not equal to only, and on line number 28, instead of just using 2 parameters for taking the minimum value, you can take the third parameter minimum itself as well.
Or min with that minimum, yeah.
Sorry, I didn't get your part.
On line number 28.
Okay.
You are currently using 2 parameters, right? Like frequency of L and frequency of O. You can take a third parameter as well, min.
Min, yeah, just min of that.
Okay.
Yeah.
But your min function you'll have to modify because it won't actually.
Yeah, that's. You can use the curly braces and it'll work.
Wait. Oh. Oh, I guess I have to.
On line number 28 itself, add a third parameter, min, and put all of these 3 parameters inside the curly braces. Curly brace, yeah. And it's a function call as well.
So it'll work?
No, put the curly braces itself as well into the function call, like this. What do you call that? Braces open and normal closed braces. Yeah, now it'll work.
Okay. Yeah, it's working. Yeah.
But you can quickly test with the test case. They might not be having that test case, But that's a good catch, Ronnie. Yeah. Yeah, good. You're able to solve that also. No problem. Thank you.
Now we can switch to next then.
Yes, please. Yeah.
So our next is like we need to get equal substrings within the budget. So 2 of the strings are given S and T, and we are supposed to change from S to T and in that you change the ith character of s to the ith character of t, and the cost will be like absolute value of s of I minus t of I. Now we are also given the maximum cost, and we need to return the maximum length of a substring of s that can be changed to be same as the corresponding substring of t with a cost which is less than your max cost. And if there is no substring from s that can be changed to its corresponding substring from t, we need to return 0. So if we look here, A, B, C, D, they have used A to B, so 1 for that, B to C, 1 for that, and C to D, C to D, 1 for that. So by the time you hit 3, and this is the largest one, the entire cost will be over. So this is the length of that substring which would work over there. And here if you see, yeah, in each character of this S, it will cost 2 to change 2 characters. So what you can see from A to C, if you go, it will take 2. Any character, like if you go from B to E, it will take 2, and C to E, it will take 2. So you can't take other character because the cost reach to 4. So only one you can change. So maximum length is like 1. And same, and can't the maximum cost itself is 0, but in change, then it will exceed your cost. And countries can have only English lowercase letters and cost be greater than 0 and less than 10 to the power 6. So any of this?
Hey, Shashank, your voice was breaking,
Am I able?
You are, but sometimes, yeah, it is okay now, I think, yeah. Okay.
So do I need to go from beginning?
No, that's fine. We understood the overall problem. Yeah.
Exactly. Yeah. So how do you approach or proceed?
So here, when they say the cost, difference from one letter to another letter, like if you take, for example, the first one, when you go from A to B, the first 2 letters of S and T, so A is lower and B is higher. But what if they are reversed? Like you have in S, the first will be B, and in T, the first letter will be A. So if it is the reverse of that, still will that be counted as 1?
Yeah, because it's a mod operation. No, so cost will be minus. When if it is, then it will give you a positive result.
Oh, they have specified the absolute difference. Yeah. Okay. Yeah. Okay.
Yes.
But I wonder if this will be explicitly stated in an interview, saying, okay, you have to have a mod operation of those 2 letters, right?
Yeah, because otherwise it will have a negative.
Yeah. So maybe we need to get it cleared from the interviewer.
Yeah.
Understand the
Maybe these questions are kept for interacting with the interviewer. Like they will keep this first hidden, and then we are supposed to ask. That's a good. Yeah. So.
Yeah. Any approaches? Yeah.
We have to replace character at the same position, right? Can we replace like in different position?
No.
No, it's a substring.
You have to compare the letters with each letter with the same indexes of the other string also.
Index.
Yeah.
Exactly.
Yeah. So the proof false will be like compute the cost at each index, right?
Mm-hmm.
So let's say we have an array and we compute the cost at each index. And now, we go in and, look at the longest sub range that sum up to the given cost, less than or equal to given cost. Right? So that makes me think of maybe we can do pre-sum, right? Once we already calculate the cost at each index, so we can do the pre-sum on it, and then we can, find the range that, up to that given cost.
You're right. But yeah, the first thing what you said, finding a cost array, that actually is a good thing. But do you really want to do a pre-sum? Can you do, because pre-sum will involve another iteration, right?
Yeah.
Yeah. Because in this case, I was thinking maybe, I need to find the longest range, right? So
Right.
so maybe not pre-sum, but like 2-pointer, maybe it could help because these
Yeah,
are positive number.
correct. So that might be easy way of doing it with the 2 pointers, right? Yeah. Yeah, you have
Yes.
some approach to displays.
No, I'm driving. I don't
Okay.
have it.
All right, no problem. But I think this is the correct approach, That is what I was also thinking. But he
I have
came with that,
written
yeah.
the code.
I used.
Yeah, okay. I think we have a couple of them, right?
Someone said someone has written the code.
Yes, sir.
Who?
Yeah, it was me, Sonal, this
Okay,
side.
Sonal, yeah. Okay,
This
let
is like
Sonal go first
sliding
and then,
window problem, right?
no
Yeah,
problem.
right.
Let Sonal
Okay.
go first, then Gaurav, you said, right? So we'll go
Yes,
with
sir.
you
Yes,
on a
sir.
second. Okay. Yeah, go ahead, Sonal.
1 minute. Are you able to see the screen?
Yeah.
Try to maximize it.
I think I have maximized it. Is my screen completely visible?
Yeah.
Yeah, it's visible for me,
It's
yeah.
visible.
Okay.
Okay. So what I did is first here I initialized a vector with the size of the string, and then like computed all the absolute difference between, like, if my string is s is equal to a b c d and t is equal to b c d f, then I've computed my vector will be like 1 comma 1 comma 1 comma 2, right?
Mhm. The cost vector, what actually Ian was saying.
Yeah,
Okay,
yeah,
good. Yeah.
yeah, this one.
Mhm.
So this is here I've computed.
Mhm.
Then what I did is I have like run till the length of the string, because my s and t string is all is of the same size. So no matter, we can take any one, s and t.
Is it
Then what
given?
yeah, it is of same length, s and t of the same
Okay.
length.
Yeah.
Correct.
Okay.
That is
Then
right.
we have our max cost. What I'm doing is I'm subtracting max cost. It is first for this it is 3. So what I'm doing is I'm just subtracting first integer, like first value from my vector, that is 1, and it will be equal to 2. Then what I'm doing is uh, like I'm subtracting all the vector indexes one by one, and then checking the length, like increasing my length and checking the length here, and I have initialized max length to 0, and I've taken one more pointer to 0. So basically it is like sliding window problem. First time on like a of I is my 1, I've subtracted that, and then I've like I is 0, j is also 0 initially, and my length will be 1. I minus j plus 1 is 1, and max length is 0, so now my max length will become 1. Now again the loop will run, and it will be on this second one, like second index. There it is, like again I am subtracting 1, so it will be 1. So max cost is again 1, which is greater than 0, so it doesn't go in this while loop. and then it is like 1 1 minus 0 plus 1 is 2, and now my max length will become 2. Like this is the comparator function. So max length here will become 2. Now again for third one it will run, and this will be like 1 minus 1 is equal to 0. So my max cost has now become 0, and I'll be again on the outside of the loop, and max length will be changed to 3. Now I'm doing it for my last variable, that is 2. When I subtract it, it is becoming minus 2, which is like less than 0. Like now I don't have any cost. So I am in this loop, and I just add again this v of j. So my j is now on 0 only. Initially it was on 0 only, so I just add that to make, trying to make it positive basically. So last my it was minus 2 plus 1, this will be equal to minus 1. So my max cost now here turns to minus 1, and j increments to 1. J will be incremented to 1. uh, Now again like my max cost was minus 1 only, which is less than 0. So I like add and j was 1, so v of j is 1 only. So I just add it, and it becomes 0 here, and this becomes 2 here. J becomes 2. Now when I see this, so this loop is not satisfied. I am outside of my loop, and then I just compute again this. So my I minus j plus 1 will be what? Uh, we were on 0, 1, 2, 3. We were on third only. 3 minus, and j was 2 plus 1, which is 0. Yeah, it is 0. Sorry, 2. 3 minus 2, 1. Yeah, it is 2. And max length, earlier it was 3. So now my loop is also completed, and I have already found my max length, which was 3. And then I return my max length.
Okay, but I have a question here. You are modifying the max cost directly, because and actually you will be destroying that value when you are going in that line number 15, 16, right? And max cost is your input to the function. So usually we should not modify the inputs to the function unless you can ask the interviewer and find out. But are you not destroying the value of max cost here?
Yeah, I am, but like we can take another, like I can assign it k to max
Yeah,
cost.
you can do that something. Yeah, that is true.
And then use k inside my loop.
Yeah.
So, but actually we are not using max cost to like return something. So that's why I thought like I can use it directly.
That's cool. But only the thing is, if what happens if your actual value of your max length might be at the end of the array, and you're doing many passes, inside this array, and you're always changing. So your max cost will always be increasing, not the same, right? It might be differing also.
It will be.
Yeah, so maybe the test cases are not that stringent for year, so it might work, but just a thing to be take care of later. Yeah.
Sorry, can you please repeat something in the last sentence? Like I was not able to understand.
No. What she's saying, she is doing is max cost. She is actually modifying it, right? So when you are modifying, when you're on line 16, when you add any value, it's not going to be exactly the same max cost which was as an input. It might change also. It might be slightly more also, right?
Right.
Yeah. So you are actually comparing with a different target every time. So your input might not be, some test case might not work, but here in this case, most of the test case might pass because they are not taking care of that or something like this.
Can you give me an example? I'm not able to think of an example where I think this is fine.
So actually what is happening is like I'm just, whenever it is like becoming less, then I'm just deducting my max cost again and again. And when it is becoming less than 0, I'm just adding some values to make it positive. And on the other hand, also incrementing my another variable which I've taken, that is j. So this is like sliding my j variable from left to right more, and and this thing will like help me to get the exact length of the substring.
Yeah. So it's a sliding window approach, and you are using both the pointers from the left side. Yeah, that's great. So that's not a problem. But I'm only worried about the input of that max cost. Other than that, everything looks okay.
I think, and this is passed, like I
It might have
submitted
passed.
it.
Yeah, sure. Yeah.
Yeah. So like if we have something like this 4, 1, 1, 1, 2. I think this is a good example which I was trying. So in the suppose my max cost for this is like 3, and now what happens is, firstly 3 minus 4, my max cost will become, I'll just remove these. So here my max cost will become like 3 minus 4 minus 1. So it goes into this loop. Minus 1 is less than 0. Then what happens is we just add again the max cost. We just add the same variable. So again the max cost here will become 3, and j is incremented to 1. Now I'm not no more in this loop. I get out of the loop. So 0 minus 0 plus 1. So max length is now 1. Now again I'm running the loop, which is now 1. I'm on the second variable, like the second index. So this will be, so my max cost was 3 here. So 3 minus 1 is equal to 2. So here it is 2 again. If I check 2, like 2 minus 1 plus 1. So max length now becomes 2. Now if I am again going in this, 2 minus 1 will be 1, which is my max cost. Now again I'll be out of the loop, and here it will be like 2 minus 1 plus 1. So again it is 2. Yeah, again it is 2. No, wait, 3. I think I was on third index, right?
Yeah, that's fine. We can verify that. That's not an issue. But yeah, overall everything looks good that way.
Yeah, if you run on this, I think it is more, you'll understand more better.
Right.
One thing I don't see this like to validate whether J is within boundary, right? Because we just keep increment J and then check it that, and what if it's out boundary, and it could throw exception.
No, actually it won't go, because both of the sizes of the strings are same, and she's iterating I from 0 to s dot size, right? So J will maximum increase to s dot size. That's the max it will go. So it won't go more than that.
Yeah, but in the inner while loop, right? Look at, she only check if the max cost is less than 0, right? And she keep incremented.
But here also we are like we are trying to make it positive, right? And
yeah, because anyway she's always using the same input array and trying to make it match with that max cost. So should not overrun, looks like, because it's passing all the test cases, right?
Yeah. It should not overrun, right? That's right.
Yeah, it looked like it appeared look like it be the n square, but actually it's only n runtime complexity.
Yeah, because it's the second pointer actually moving. in the second
Yes.
while loop. Yeah.
Great.
Yeah, no problem. Yeah, I think Gaurav wanted to share, right?
Yes, sir.
Go ahead.
So actually, I did the same what she did. I used that similar sliding window thing. So basically, let me take the same example. That the first one, what I did, I I had the absolute difference of their ASCII values, which is 1, 1, 1, and 2. Okay, so it was done till line number 9. Okay, so now I took four variables, which are left, 0, sum, and answer. Answer would be the final answer that I would be printing out. Okay, so I took two pointers, that is left and right, which is basically required in this sliding window thing. So I started these two pointers I and j from 1. Okay, I started this thing. So what I did, um, I started
INJ means
adding
left and right, right?
yes sir,
Okay.
sorry, left and right. I should
Yeah, no
I should
problem. Yeah.
yeah,
Got it.
these are left and right.
Mhm.
Okay, so I start iterating from the very first element, and then what I'm doing, I'm adding the values of the particular element to my sum, and I am adding that thing, and in between I am also checking whether my sum is exceeding from max cost. If it's not, okay, uh, if it's not, okay, so
You
and
are
at the
calculating
same
max so far.
and
Yeah.
at the same time I'm also um, having a notch of what my final answer would be, and final answer I'm taking. Is somebody saying something?
No, no, it's okay.
Okay, so at the same time also um, having the tab of my answer. And what I'm doing, so in this second iteration, it's still the same, like 2 is less than 3. In third, it's the same. It's the same thing. Okay, so here what I did, here it's 1, here it's 2. Till now the maximum answer we have, where it is equal to 3 till here, till line number 33. The answer, my final answer is 3. So now what I'm doing, as I iterate to the next element and I add the value of it, my value of sum would exceed from 3. Okay, it'll be uh, it
5.
will be 5. It will be 5. So if it is exceeding by 3, if it is exceeding from 3, what I've done, I have um, now I use this um, left iterator. I start deducting the values. I start deducting the values from the elements which I earlier um, which I earlier added up. So what I'm basically doing in this sliding window thing, I am first of all finding out all the possible sub arrays which satisfy this thing of having the sum equal to 3, less than or equal to 3. I'm first of all checking out that, and then after out of those, I am having the answer which has the maximum of them. So what I did in this 34th line, I iterated this ith element to the first element. I deducted that, and the answer would then have been, 1 second, I guess.
Yeah, because it is max. You already attend that max value, right?
Yeah.
So
1 second. Actually, I did in this thing. Yeah.
okay. So your left value actually moved to the third position, right?
Yes, yes,
Okay.
yes.
Okay.
So in the same, it's happening. We are saying that we have to do this till the sum is greater than max cost. So still we will be iterating over to the next element. Still the sum is greater than 3. So then we will do the same thing to ensure that this condition do not satisfy. So what we did, we again moved to the next element. We again subtracted the value of that element, which is second 0, 1, 2, to second element from the sum. Now we see that our sum is equal to 3. So now we take the value of that, which is equal to 2. So, we have to notice one thing, like from line number 34 to 35, we are not having the value of answer A and S. We are not having the value because we are still in this loop from 14 to 18.
Yeah.
We are in that loop, and we are not checking the value. We are not updating our values of answer. So so after, at the end of 36, we are having a final answer. We are having our final answer, and then we check. We have a check of what is maximum between them. Our previous answer of previous value of answer and our current value of answer, whichever is maximum of them, we'll have that as our answer. So in this case, we checked with 3 and 2. Our answer would be then 3.
Yeah. So your final answer is 3 in this case, and then you will be returning that value, right?
Yes, sir.
Yeah, no problem. So you are saying the outer while loop is expanding your sliding window, and the inner while loop, it is contracting, and you are contracting based on if it is greater than the max cost, right?
Yes.
Okay, no
So
problem.
basically this 14 this inner loop, what it is ensuring that I am having the that my current array is ensuring it's been ensured that the current array's maximum cost sum should not exceed by the given value, which are in this case is 3.
Right. No problem. Yeah, that's good.
I think I was doing opposite of this, right? Like inner and outer loop.
No, yours was also almost same.
I mean, definitely.
It was same only, yeah.
Let's move on to to the last problem.
Yeah.
Like we are already at.
I have one question on the previous slide. Do we need the vector? Sound like we don't need the vector, right?
Yeah, you can optimize
we can
that
create
on
it on the fly, so that's we can save some memory.
Yeah, we can do that also. That optimization can be done. Yeah. I think what Gaurav is saying, right? Can we move to the last problem?
Yep. I believe the key takeaway from both of the solutions is that to recognize this is a sliding window pattern.
Yep.
Okay, so that's the main thing. And the solution that Sonal presented and Gaurav presented, both are similar. At one place we were subtracting the max cost, and at one place we are adding up to the max cost. So both solutions are pretty similar.
Yeah.
And also, we talked about modifying the input parameters. So I just had to say that whenever we are passing the parameters by reference, we should avoid modifying it. But if we are passing by value, it should be okay to modify it. I don't see any issue with that.
No.
Okay.
Sure. So right. Yes.
Excuse me, sir. Your voice is breaking, sir.
Am I audible right now?
No, sir. You're still lagging.
Yeah, no problem. Yeah, go ahead.
Yeah.
You are still not audible. You are still lagging.
I think he has Yes, logged out. We lost him.
Yes, sir.
Yeah. Okay, maybe I'll just quickly go over that problem. That is the last one, right? Okay. You guys hear me? See my screen?
Yes, sir.
Okay. So this is the last problem, 1218, and it says longest arithmetic subsequence of given difference. So we have an array, an integer array, and we are given another input called difference, and we need to find longest arithmetic subsequence of the given difference, right? So we have example 1, which says input array is 1, 2, 3, 4, difference is 1, and we can see that the output can be 4 because all the 4 have a difference 1, right? In this case. So we can count all the numbers and say that can be a longest subsequence of difference 1. Come to example 2nd, the difference is 1, but you don't have a single element, at least 2 elements which have a difference 1, but a single element itself will be 1, right? So therefore the output is 1. And in the third example, if you see, we have about many elements and the difference is given as -2. So this will be an descending values, like if it is 7, then it will be 5, 3, 2, 1, something like that. So if you find this longest subsequence with difference -2, we have about 4 such elements which match that difference. They are 7, 5, 3, 1, and so hence our output is 4. And the constants given are 1 array length will be maximum 10⁵, and then array or maybe the difference both will have the same values in the range from negative value to positive value. Okay, so we have negative numbers also in this case when they are not in any example. Okay. Hey Shashank, you are back. Okay. We lost you. So you are here?
Yeah. Go ahead.
Okay. So I just explained them the problem. So anyone has a question on that problem?
No, sir.
Okay. Any approaches?
Sequence has to be
I use this dynamic programming approach.
Okay. But would you like to first describe what that was?
Okay, sir. So, sir, it's like I took this unordered map, and I inserted each and every value of this this array. If we take this example of example 3, so I inserted each and every value 1, 5, 7, 8, 5, 3, 4, 2, 1. Okay, so yeah, I did that. So what I did, I took a loop, and I started iterating over this our given array.
So when you said you took an unordered map, so what are the keys for that?
I'll start inserting those keys. Maybe I could. Okay, you are sharing. You are doing this thing. Okay.
I have one question. Can I ask that question?
Yeah, go ahead.
If you have sequence like 1, 7, 5, 3, right? And if it is what is the difference is -2, then what is the output?
3. So because 7, 5 will be -2 and 5, 3 will be -2, right? So 1, 2, 2.
So if you have again 1, 5, 7, 3, then if you have 1, 5, 7, 3.
1, 5, 7, 3. So this will be 5 and 3 only, right? So this 1 and this will be 2.
Yeah.
That is what I think. Anyone can correct me if I'm wrong.
In 1753, it will be 3, right?
Yes.
So this will be 3, 1753, but here it will be 2.
Yeah.
Even 7 and 5 can be, right?
No, it is a subsequence, right? So subsequence will always be in an increasing, right?
Yeah.
It will go in one direction, not only increasing, either left or maybe, I'm not sure, maybe right also, but it has to repeat in the same direction.
And you can skip any elements because it's a subsequence.
Yeah, you can skip any elements. Yeah. So you can just remove these two elements, and then this will be your subsequence. Only these two elements.
Yes.
Yeah. Okay. So Gaurav was going about this, the first example, right?
Yes, sir. Third example.
Yeah, the third example, whatever written here.
Yes,
Okay, on the
yes,
top.
sir. Yes, sir. So I took this unordered map. So what I have done, I'll start iterating over these elements of this given array 1, 5, 7, 8. So okay. So I'll start with first element. What I'll check if that element is already present in the map. Like for this case, for 1, if it's not present. So then what I'll do.
So you're checking the first. If it is not present, okay, we have a map here, okay?
Yeah.
And then what are you trying to do in the map?
Maybe I can share my screen, okay?
Okay, go ahead.
Yeah. So I took this map. I took this map.
Yeah,
and then,
I would. Sorry, Gaurav, to interrupt you.
Yeah.
So if you could, yeah, that's fine. Don't explain the code, but if you just explain how did you do using that example, and then we will go through the code.
Okay.
Yeah, that will be much
easier.
So,
so I'll start iterating over this array. Okay, I'll check each element. I'll check with each element if that element is already present in the map. If that element is already present in the map, what I'll do, I'll just check whether the given element in the key in the map minus the difference, minus that difference if that has already come. I hope you got my point. Like,
okay, so you are trying to say that in the map, if you first don't find that element, okay, so you first set some value, maybe the base value, something like 1, okay, but then when you find a value,
this hint was this line. I'm doing this thing that let TPI be the maximum length of the subsequence of the given difference whose last element is I. What I'm doing, I'm basically calculating like till my first element. What's the answer for this? If the difference is -2, then till 7, till 8, till 5, till 3, till 4, till 2, and till 1. And in a subsequence, if there is a number, if there is two number, if we take the case of 3, okay, 7 and 5, when we go to this 5 key with which is equal to 5, we check whether this key minus the difference is 5 minus of -2 is 7. What was the answer at there? And whatever was the answer at there, will add 1 to it.
Yeah, so you are trying to say that when you find any time, that difference value, which is already in the map, you take that value of the map and you increment it by 1 because you already found a match, right?
Yeah,
for
exactly.
the difference. Okay.
Exactly. Let's say, suppose you have 2, 7 and 1, 7 have a longer sequence, then what decision would you make?
Sorry, please could you repeat?
Like you're at 5 right now, right? And you look back, that's 2, 7, right? Like, let's insert another 7 in there, right? So now you have 2, 7 in there.
He's saying that you have 1, 5, 7, 7, 8, 5, something like that. Just copy that array, whole array.
Yeah.
And just insert 1, 7, and then, but that should not make a big change, right?
It could, because 1, 7 could have longer subsequence, right? The other one
could have shorter, and we.
Let's take this case, like
Okay.
in continuation there are 5 3, there are 3 5. Okay, so for this the answer, what would be the answer by now? It will check, that whether the whether in the given whether in our map, it, if there is an element which is equal to 5 minus of minus 2, which is equal to 7, and then it will look to this, its answer is equal to is equal to x. Okay, and then what we will do, we'll just update the our answer by saying that
yeah, so we'll just update to 2 in this case, right? Yeah,
it will be x plus 1.
Yeah.
Then we will go to next element. We'll check the same 5 minus of minus 2, 7. The answer of 7 is still x. It is still x. So here the answer would be say, we could say it will be the same. It will be same.
Yeah.
And same with will happen with this.
Yeah, that's okay. We got that. But what Leon's question was, like, if you already had a 7 earlier, so when you're looking back from 5, which 7 you are going to actually take? How are you going to make a decision on that?
You are saying this.
Yeah, if
you are
had
saying
2
this.
7s, yeah. But Leon, in that case also,
Yeah,
both 7s will be 1, right?
He will be unique only, like only
Yeah,
1 7 will
exactly,
be there in the map.
Yeah.
Exactly. That's what I'm trying to
No,
explain
it won't
here.
be
Like,
unique. You will have 2, right?
there
It's
are
another map. Sorry, go ahead. Yeah.
Yeah. What I'm saying, like, we are taking map. In map, this 7 and this 7, they both have this same place. Like,
Okay,
at the end, it'll be this DP7. DP7 is equal to 1. We are just iterating over these elements, this array. But
no,
when
let's suppose you have, suppose you have on the second 7, you have 1 2 0 1 2 3 4 5 6. Between. Okay, between
like,
7.
Yours is like
Between the 7, you have 0 1 2 3 4 5 6. Right, that will make 2 7 different.
Yeah.
Your voice, I think so.
Okay, maybe we can take this statement as a test case and run Leon, so things will be clear.
But I don't think it will matter even if we have like 2
Yeah.
duplicate numbers.
Should not, yeah. Because if you have a different 7, right? So it is going to only look for the largest subsequence anyway. So it will surely go and find the largest one, right?
Yeah, as long as the sequence is same, the length is same, it doesn't matter.
Yeah.
It looks like.
Can somebody
Like
explain on the whiteboard? Like, it is confusing this way.
Okay, so what he was trying to say here, in the map, if you start from the first element, okay, so the first element is 1. Okay, we don't find that in the map. So he's just marking this as 1 first. That value will be 1. So when you go to 5, you still don't find that in the map. You put that as 1. 7 for 7 also he does the same thing. For 8 also, right? But for 5 again you find that, right? So in this case it is again. So for 5, so our difference is in this case is minus of minus 2, which is equal to 7, right? So you find that value here. And the value in this case is 1. So now when you have found this difference, so you will add here this value plus 1 because you have found 2 elements here, right? So then you go for 3. When you go for 3, you do the same thing. 3 minus of minus 2, which is equal to 5. So you find that 5 is in the map. So when you find 2, and the value of that is 2. So here you will add 1 more because you have found another element to that which matches the difference, and therefore you will make it 3. And for 4 you don't find it, so you make it 1. And for 2 you don't find that value, right? So nothing that value, so you make this one. But when you go to 1, So 1 of -2 will be equal to 3. So your value in this 3 is also 3. So you add 3 plus 1, which will be 4. And this is your maximum value. Then you return this value. Is this clear?
Yes, sir.
Yeah.
So one denotes that one element of that sequence is present. Yeah.
Sorry?
I was saying one denotes that at least one element of that sequence is present.
Right. So it is like a base case, right? For all of them. You at least have to have some value there. Yeah. You can go ahead with the code walkthrough, Gaurav.
Okay, sir.
Exactly. Yeah.
Yes, sir. Yes, sir. So I'm like doing this inserting thing and checking thing at the same time. Okay, so so I'm just running one loop. Okay, so I'll first check whether the element is present in the map map or not. If it's not present, which is in condition 9, then what I'll do, I'll also check whether ARR, that element value minus k, minus the difference. Okay, so it was the difference minus k. If that is also present in this map, if it's not, then what we would do, we would just insert this pair ARR of I, comma 1. Okay, if this ARR I minus k, if it was present, then what we would do, we would just make a pair ARR I, comma ARR I, comma map of this thing, because it was present, it is already present in this map, and we just add 1 to it. We would insert this thing, and in else case, if this array, if this element is already present in that, and at the same time, this is the case like where we were discussing this thing, like if it's if the element minus k, if it's not present there, we will just continue with that thing, because if that element is already there, if that element is already present and it's not, and it's second parts, I would say like that, if this is not present, like we can't do anything.
Right.
It's just repeating itself. So, and if it is present there, what we would do, we would just update the value of map ARRI equal to map ARRI minus k plus 1. And then at the end, we take the maximum of the value store.
So you are every time on line 29, you are actually taking the max so far, and for every iteration.
No. This is inside this for loop.
Right. So
I have done this. I have done this after this. I just check this for this thing for 1. Like in the initial, I initialized with this maximum to 1. So at the end, I just compared the value.
Okay,
I compared the values.
Yeah, that's good.
Yes, sir.
What is the need of having line number 9? Like, if we do not check, since we are at I, then error of I is already, we have achieved it, right? Then why don't we only check for error of I minus k? If we found it, then well and good. We can set current value of like map of error of I equal to map of error of I minus k plus 1. But if we don't find error of I minus k in the map, then we can simply set map of error of I equal to 1.
Yeah. I actually got that point, but I was just, in order to make myself more understandable, I did all this thing explicitly.
Yeah.
So just confirming that I'm not missing out on something. Line number 9 text can be removed, right? The if condition on line number 9.
like
because if we find the previous element, then we can simply set the value of like dp of current will be previous plus 1. But if we don't find the previous, which is by previous I mean error of I minus k, and if we don't find the previous, then we can simply set the current value to 1.
yeah.
Does that make sense?
Perfect. Like yes. Like if it is already present there, we would just update the value. We would just update the value by having its its counterpart now, that is ARR I minus k plus 1. Yeah, that would be fine.
Yeah, okay, Gaurav. One more thing, there is a message on chat from Gaurav, other Gaurav. So he's
Yes,
saying that, yeah, this is a DP solution. Okay, fine.
yes, sir.
But what if I don't know DP? And what is the real intuition why you came with the DP solution?
So basically, I took the hint.
Okay.
So
I took the hint.
the problems are there, right? On the top of that, we are building the larger array.
So, and one more thing, if you want to go with this DP thing, like the main intuition also I came with this thing, like why do we use DP? DP, like we have to build by blocks. If we could just simply break down a problem into smaller problems, and at the end we could just add all of them. That is I guess pretty much we did here. Like we first calculated till here, then till here, then till here. So every time we are also using our previous answer from this scene. So I guess
yeah. So you are using that sub problem and substructure, everything, right? The two feature.
I think I can have some some good inputs for this. I mean, because I didn't came up with the DP approach in first, and like it was not my need of question. My first approach was like a simple n-square solution. Basically, I iterated over for I in like for I equal to 0 so to n, then j equal to 0, I plus 1 to n. I simply compared if it is possible to have like this jth element as the next element of the ith element. Then I came up with the n-square solution. Obviously, it was thrown clearly. Then I improved the n-square solution to achieve a worst case of n-square. By worst case of n-square, I mean is like when I'm in the middle of the array, then I've already computed the values to the right. So I simply store the values to the right. And when I reiterate over the array, then I use the right value that I've already stored instead of like recomputing it. I mean, can I share my screen?
Yeah, please. Yeah.
Helpful, I think.
Yes, Gaurav. It's actually similar to that, this longest increasing subsequence thing.
Oh, you're replying to his chat?
Yeah, I think it's...
Yes, sir.
Yeah, okay, no problem. Yeah. Let's see, Ronnie has some solution. Yeah, so he's sharing it.
Yeah, similar to the longest increasing subsequence, but in that problem, that take like big O of n square, right? This one, why it take only big O of n?
No, that's true. But see, coming to this solution is not an easy task, right? So we need to build on something, because in the interview you won't even recollect this so quickly.
Yeah.
No, I'm talking about runtime complexity.
Yeah, absolutely. Yeah,
that's the other one. Yeah, the other one that take O of n square, but this one somehow we optimize it with only big O of n.
Right.
Maybe here we have the difference. We know what we need to compute, right?
Can you see my screen?
Yeah, we can see your screen. I think it was Pradeep, right?
Yeah. So Leon is asking why it is a big O of n for this one, and for the long longest increase in subsequence, we have O n square, right?
Yeah.
He's comparing why we are able to reduce the time complexity for this one, not for that one.
Oh, yeah.
Yeah, the only thing here we know the difference, right? Like difference we need to calculate is -2.
Uh-huh. And there you have to find the difference, yeah, because that is the longest subsequence you have to do.
Yeah.
Right.
So you
makes sense.
Okay.
Yeah. Okay.
This was like on line number 3. This was the first approach that I came up with, this n squared. So like what the Gaurav discussed in Gaurav's approach, he was calculating the values for the first, like he was starting from the beginning, right? Whereas I'm starting from the end. So I'm iterating from 0 to n. Then for every value of I, I'm checking if going forward is there any value which can create an AP. So if I found a value, then I replace my current value, like this was my current value starting with error of I. Then I replace my current value of error of j. If I found a error of j which was a valid one, and then I like loop in this. So this was basically n square solution. In this I realized that, like, if I take an example, so basically if I run through the code, it is basically I'm at 1. I check if I can find a valid 3. Yes, I found a valid 3 here. In this, at this position, like j is pointing to 3, and the current element will be 3 now. And now going on from like onwards, I'll see if I can find a valid 5, but I was not able to find one. So my maximum length will be 2. Like when I say maximum length, I basically mean that I am definitely including this value I. When I include this value like 1, what will the maximum length I can achieve? So it will be 2. When I include this, what will the maximum length I can achieve? It will be 2 again, like it will be 5 and 7. So this was my first approach. In this, I realized that if I am already calculating the value of 7, like when I'm at 1, I'm finding the values of all of them. Then when I reach at 7, I'm recomputing the values for 7 from starting from 7. So my second approach was to store these values, like in this.
So before coming to the second approach, Ronnie, did you run that this one in our leak code?
I ran it.
So
it's used TLE.
Oh, okay, good.
It's through TLE.
So it is TLE.
Yeah.
No problem.
Then I went on for this first n squared approach. In this, basically what I did was I simply stored the last values. So when I'm at 1, I know the value computed will be 3. So the next value is 3, right? So I jump to 3. Like it's the same as the previous approach, almost similar. It's just when I'm at 3, I've computed the value of 3 now, right? Before returning it to 1. So instead of just simply returning, I also store the value of 3 so that I don't repeat like the entire function for loop for 3. Does that make sense?
Come again, please. I actually missed that.
Yeah, okay. I'll just run through an example. So basically, I'm starting from 1, like I'm starting from the end. So when I'm at 1, can I find a better answer? Like when I'm at 1, I mean I only have this array.
Right.
I only have this array. Okay. So when I'm at 2, I mean I only have this array. Okay. So now at 1, I can see, can I find a better value? No, I cannot. So the answer will be 1, which is like initialized. Like the current length is initialized to 1, right? Then when I'm at 2, I find, can I get a better value? Can I get by better I mean like longer value, longer length.
Yeah.
So no, it's not possible. Then it will be 1 again. For 4, yes, it is possible. The difference here was 2, right?
Right. Yeah.
Sorry, minus 2. Yeah. So 4, it is possible 2, right? So now at 4, I store the value of 4 itself. So at like DP of 4 will give me 2. Not actually 4, like not actually DP of 4. Instead of 4, I'm storing the indices. So this is 1, 2, 3, 4, 5, 6, 7, 8. So basically DP of 6 will give me 4. Sorry, 2. DP of 6 will give me 2. Does that make sense?
Yeah. Because you are having 2 as the previous one and 4. Yeah.
Right. So now when I have 3, I see do I have a 1 in like in the indexes 6, 7, and 8. Like, yes, it is for there was a 1 here. So now I have fetched a value of 1, and simply, so the dp of 8 returned me 1, right? So dp of 5 will be 1 plus 1 will be 2, right? Does that make sense?
Yeah. That's correct. Yeah.
So this was like, by this I was able to reduce to worst case of n square. In the previous approach, it was always going n square, right? In this approach, but in this approach, it will go to the worst case condition of n square, and not every time.
Okay.
So this was my second approach. Then
So
the third approach
was
came
this
when I
passing
realized
your
that
daily? Was
this
this
one?
passing your daily, huh? Or not?
Yeah, this was. I mean, I didn't run it.
Okay, no problem.
So now this was my third approach. It is basically n log n. It's not even n. So in this, what I did was I simply, like, if you realize in the previous approach, it was going n square because of this for loop, right? Because I had to find this value. So basically, yeah. Okay. So if you look at the example on line number 42, when I'm at, let's say when I'm at 5 and the difference is 2, I want a value, let's say when I'm at 3, okay? When I'm at 3, which is index 5, I want a value of 1, right, to complete this AP. So how am I finding this value is using this for loop on line number 30, right, which is taking again over n time complexity. So I reduced it by like storing it in an array and storing it in an ordered map, and then using binary search for finding this value 1.
Okay.
So the two constraints were that I had to find a value. I had to find the value of 1 in this array 3, 4, 2, and 1, right? So I know that the index value of 1 should be greater than 5, right? Because then only it can make a subsequence, right?
Yeah.
So I basically stored that in an unordered map, as you can see on line number 48. And then I used the lower bound, which is like basically upper bound, which is basically like binary search in. And then I found the value, and then and the rest of the logic is same. I simply replace this for loop by a binary search. So this is now down to n log n, and this is obviously passing test case, but obviously the time complexity runtime is pretty bad.
But still it is passing.
And
yeah,
it's still working. It's the only difference is basically I had to do binary searches because I was traveling from like the end part. So I was starting from n minus 1 and I'm going towards the front.
Okay.
Had I been doing the way the Gaurav was doing, like if I start from 0 and then go in, then probably I would have approached the same way as he did, and I wouldn't have to do a binary search.
Okay. Yeah, but in binary search, when you did on line 63, right? So when you are upper bound, it means that what value you are looking for? Value I, right? You are searching for value I.
I is basically index. So I am searching for value of, let's say, if we take the same example, I'm at 3, which is index 5. I'm looking for value 1 in the unordered map, having an index greater than 5. So in this, you can see on line number 50. Then the unordered map, I'm basically just pushing the elements and their indexes. So this is the unordered map. It's basically storing the element and all the indexes present on.
Yeah. So you are bucketizing all of them, right?
Right.
Whatever is that. Okay.
Right. And if I found the value, I'm simply like adding it to my current length and simply storing a maximum point of maximum variable, which stores the maximum length, and then returning the answer finally. So basically, just simply that.
Okay.
Does that make sense? Was it helpful? Is someone was asking like, how did you reach to the DP solution or something, right?
Yeah. Gaurav was asking, so yeah. He's saying, please pose the question that need further discussions on. So, yeah, actually, it's for our whole group, right? So if people have questions, then they will ask you.
Yeah.
Cool. Okay, I'll stop sharing.
No, that's okay. So actually what I understood from yours is you started with the n square solution, right? Which was the brute force. Okay. The first
Right.
one. Yeah, this one. And here it is,
Right.
if you look at it, is you started with the first element and you started comparing the difference. When you came in the second
Right.
for loop, you just look for a difference, which if you found a difference, then you kept on incrementing the current length. And then you are taking the max length, that was the max of r on line 15. Okay. And if what is, you only have that optimization in 16 and 17, that is still fine. But if you didn't find it, then you were actually continuing on the for loop on line 6 and just going ahead with each and every element. And therefore it was n square.
Right, that's right.
Yeah, but still it is a workable solution, right? That's a complete working solution.
Yeah, this is a complete working solution. Obviously, it's showing TLE, but yeah.
Yeah, TLE means it is working, right? So only it's the optimization we take care of. And then if you go for the other one, you had an optimized solution for the brute force also. And then you jumped on to the binary search solution. And you just optimize the inner loop here by using a binary search. So therefore your solution was n log n.
Exactly, right.
Yeah, only the
And then
upper
at last
bound whenever, yeah, the last one was the same what Gaurav is going. Yeah, only the upper bound when you see this one, the upper bound actually it looks for a value greater than whatever the value you are passing, right?
That's right.
It won't find if even if it has the same value, it will just not give you that value, but it will give you the next value.
It's basically, it's not I, it's basically index, if this helps.
Yeah, that's fine. I got that, but I was trying to understand what.
Right. So when I'm at current index, so again, when I'm at like index 5, which is 3, then what I'm looking for is the value 1, right? And the value of 1, I want the value of 1 should be at the index greater than 5, right?
Therefore, you look for that index.
So that is why I'm just doing a binary search.
Yep, makes sense. No, no, I was just trying to understand for me, my sake only. That's fine. Yeah. That should be fine. So then you had the last one was the DP solution, and this is the way the whole process was to come to the DP solution.
Right. Yeah. That's right. I'll stop sharing.
No problem. Thank you. Yeah.
Can you please share the code on the channel? I just want to look at the 3 approaches later.
Yeah, sure, I'll do it.
Thanks.
Shashank?
Yeah, it's like same as, I mean, I'll share it. So I think, yeah, it's similar to like what, like exactly DP, just like this is the different, I mean, for the current element, we'll try to find what would be the next element. And once you find that element, just increase its value by 1. And out of the, what you say, map, just extract the maximum length which it is having. Am I audible, right?
Yes. Sorry, go ahead.
Yeah, what I was saying, for every element, I'll go through the array. And for each element, I'll try to check what would be the next element depending on the difference. And once if I find, I'll just update the counter by 1. And at last, just I'll return the maximum length, the maximum value which is present in that array.
So on line 13, you are creating a dictionary.
Yeah.
So what does that dictionary take as an input?
It will take 1, 2, 3, 4 and give a value of 0, 0, 0 to everybody. I mean, key will be your element and frequency will be 0, 0. This int will give 0 to each of the elements initially.
Okay. And then when you start iterating the whole array, and then for each and every element of that collection,
it will try to check in the map. If it is present, then it will increase. Otherwise, automatically it will set 1.
So I didn't understand the thing like array. Okay, that's the value. V is the value. Value minus your difference. Okay. So you are just going to
like this will be much
right. So it is like you are creating an DP of a larger length, right?
Yeah.
And you are not using all the components of it. We are just using the ones which are in that difference range.
Useful. Yeah, exactly.
Yeah, but it is 3 to 4 line code. That is the coolest part of it. Yeah.
Because of the Python, that's it.
Yeah.
Otherwise, I think we have to explicitly do these things in C++ or other language.
Yeah.
No, I think even in C++, if you're doing, you have to collect the mapping, and then you can do the same thing, right? Because you're doing element minus difference.
Yeah, but number of lines of code in respect of that, it would increase.
That doesn't matter. But the thing is, I didn't get this element minus d. Can you explain that?
Yeah, sure. See, let's say you are at 2. Okay. Now, next element, what you will get? You want 3, right? 2 plus 1 should be 3. Or let's say if you are at 3, then current element is 3. Then what you'll do? Difference is 1. So 3 minus 1, 2. Now you'll try to find 2 inside the map, and corresponding to what is the frequency of it. Whatever frequency of 2 is there, just add 1 to it. That will be the frequency of 3.
So, okay. How did you get into this intuition?
In AP, what you say? A plus D is equal to.
Okay. Yeah. Okay.
N plus D. This is equal to N plus 1, right?
Yeah.
So if I have, you just transpose D that side.
Yeah. Okay.
It will be. Sorry. It will be minus of D.
Yeah, that is.
So it will be like that again, order of n only. Like, but I'm just traversing the array at once, and at last, this max internally will take again order of n. So overall 2 passes it will be, but time complexity will be O of n.
Yeah. So in the chat, Gaurav is saying like if we have further discussions on some of the questions which we run in this daily LC sessions, so we can bring those questions in our Sundays meetup, right?
Morning,
Yeah, so we can have a detailed discussion about it, and someone who is more knowledgeable on some of those subjects might actually pitch in, because that will be a larger audience also, right?
So we'll record the problems every day. I mean, which is like intricate or.
Yeah, what I get from his chat, it seems like we directly jump to the problems which are almost similar on the discussion forum, right?
Exactly.
Something like that, and then we just go ahead. We don't actually really verify whether it is the correct one or not, or how did we come to that, and all those, right? The intuitions and everything. Because if someone who joins new, he doesn't understand that. Also, we also don't understand, that's sure. Some of them we just go and pick up from the discussion. But if someone is helping us build up, like how Ronnie came up with the solution, right? Slowly built up.
From scratch is speaking.
Right. So because that is the way we'll have to follow process in the interview, or else just coming up with a DP solution will be very difficult. So how to build up, yeah. So that actually, that process we need to learn. So I think this is a very good suggestion what is giving. So we should, keep a tab of all these questions which are very important. We can actually take them up on the Sunday's session. We can mark those questions or the problems and the approaches, what we really felt it is okay, but we still not sure about it. Correct? That is what I think I get from this. Yeah, that's a good suggestion, I would say.
Yeah, sure.
Yeah, and what about the other people? What they think?
Yeah, I think we should first try to come up with the intuition, right? Even if it is TLE, we should try to come up with the intuition and then try to solve. Yeah, absolutely. What Ronnie did was a good example.
Right.
Yeah,
right.
I did.
Yeah.
I mean,
because
intuition for DP is like here you can say longest word. It was similar to LIS kind of, but still coming up with. I mean, I have to go through discussion and all, but after that, forming an intuition, seeing this problem, it looks DP. I mean, because of these words and the language of the problem.
Because
Right?
we should try to solve how in the interview we solve, right? First, we'll
Exactly.
try to come up with
Go
a start with the explanation as okay. For me, when I explained, right, Santosh, when I saw first time, so for me the first thing came was the difference between each element, going through each element, keeping 2 pointers. Yeah, so that is the first thing which came into my mind. So I think I don't know, but maybe if you keep solving, you might directly jump into DP.
Yeah, you are correct, Pradeep. I don't think anyone jumps into DP. At least for me also, I've been seeing so many problems. But it's not easy to find out. Even look at the problem and say it's a DP problem. It's very difficult to analyze that.
Yeah. So maybe in the interview, like what they do is, as far as I've seen, they'll give you a clue. Oh, okay, you can solve with the list or solve with the unordered map. So then you can really go to that next stage. Yeah, first we should get to the intuition. Oh, okay, and then solve with the AP. Like you explained the arithmetic progression, right? So unless you explain that, like I was saying, what are you trying to do? Element minus D. So yeah, I can write the same thing in C++ even in 3 lines. So that's not a problem. But understanding why you're doing what you're doing is the main thing.
Intuition matters.
Yeah.
Yeah, we should try to discuss that. That's very important.
So every day we'll record any one problem. I mean, which requires a lot of.
No, I would say all the problems instead of code, we just walk through the code, right? We don't have to explain more in the code also. That's fine. What is the approach if we discuss more on whiteboard? That will be helpful for everyone.
Yeah, one more thing I want to add is like first we should discuss the whiteboard one and then try to say like I've used the data structure rather than trying to explain the code, because people it's very difficult to understand someone's code and going through code is boring. So you can say I've used unordered map, I've sorted this that should be enough, I think, rather than going in detail with the code. I'm not sure.
Quickly you can walk through. First you give the explanation on whiteboard.
Yeah, explain on whiteboard, and then you can say I've used these data structures or these standard template libraries, and then quickly walk through the code rather than be in the code for a while. Yeah, that way you can also reduce the time.
Yeah, sure. I think from tomorrow let's start doing that. So it will be helpful. At least whatever possible we do, and if it is not possible, then we pick up those problems, for Sunday, right?
Yeah.
Audience are also there a lot. Maybe we will get more ideas.
Yeah, sure. And actually, Ronnie, you shared this one in the chat. It will disappear. If you can actually post that in our Discord channel, it will be helpful for all.
Permanent.
Yeah, sure. I'll post it on Discord.
Please. Yeah. Thank you. Yeah. Okay.
On Sunday, the timings are the same.
Oh, Sunday it is 9 p.m. 9 a.m. EST.
And 9:30 and 9 p.m. IST. I think it's
9:30 p.m. IST.
IST 9:30. Yeah.
Okay.
Yeah, we can stop the recording, right?
I think you are the host.